Hello everyone, I'm Neha Sharma. I'm going to give you a quick overview on my project, what I did and how actually it works, and how you can run the project as well. So starting up, I did my project on doing the cryptography on images. Whenever we talk about computer network, whenever we talk about people having a conversation on a network, we are always worried about how the data is encrypted and if it can be stolen and if it is at risk or not. So that's the focus of this project, but instead of focusing on the textual data, I have instead focused on the images in here. So I did the encryption and decryption using two algorithms, and these two algorithms that I have used are AES and RSA. So they are pretty much famous algorithms, if I say, and they work well whenever we talk about the encryption and decryption. They're pretty promising, so that's the reason I went ahead with these two. Then the implementation. So I did use the Google Colab notebook in here, and I did all my coding in Python. These Google Colab, like all the data that I'm accessing here, the images and everything is stored in my Google Drive. If you can see here, this is my project, CN project, and here I have like these three images. Then I have these two Colab notebooks that I have implemented, and I'm using these three pictures in them. So let's have a quick walkthrough through both of these Colab notebooks and how actually they are working. And just a little point to add here, if you want to run the project, then you will also have to create a project, basically a space in your drive, and then you should be able to run my Colab notebook. So that's how it works. And now starting up with the RSA algorithm. So here we are importing the libraries. So here you can see I have I have first mounted my drive with my Google Colab notebook so that I'll be able to access it easily. Then I'm importing some libraries that I need in here and creating some variables that I would be using through the whole program. Then these are the steps in the RSA algorithm. So these are pretty common steps that are like basically everywhere. Whatever implementation of RSA you're doing, these steps will remain the same. So that's why I have shown them in one place instead of just showing them all over the place again and again. So whenever we are doing the encryption, the program would just call these functions and it would work that way. So first step is creating the two large prime numbers P and Q in the RSA algorithm. So we did that, we got the value of P and Q. Then we started up with step number 2, that is calculating n equals to P into Q and Euler-Totient. So we calculated this, and after that step 3 is about calculating, like finding the value of E is the encryption key basically that will be used here, and then we calculated step number 4, that is finding out the D. So all these steps are basically like very well mentioned in my report as well, and these are like how the RSA algorithm is made, and these are all the steps that we have to follow whenever we are implementing RSA. And I have implemented it from its core, like I have not used any libraries or something, so that's why it's a pretty vast program. And then we moved ahead with the RSA algorithm with image 1. So here now we are coming to the main task where we will be doing the encryption and decryption. So these are the two variables that we'll be using for calculating the time that will be taken by my algorithm. Then here we are doing the image processing. Now what I mean by image processing is that what I did in here is, if you see, I was having this big picture and I just compressed it to a specific size. So I'll be doing this for every image, may it be in AES or may it be in RSA. I will be doing that and this so that every image is on the same page and I should be able to compare them easily. So that's one thing that I'm doing in here. And once I have the image that I want, then I moved ahead and I created a histogram. So this histogram will show you the intensity and the count of every intensity, just to show how the pixels are distributed and what actually we are having in the graph, right? And then we did the image encryption. So this is what we have for our initial image. Then we did the image encryption. Then in image encryption, this is the step number 5 encryption, and this is very specific to every images encryption. It's not same. So that's why we have implemented step number 5 over and over again for every image that we are encrypting. So here it is. Now this is what we are doing, and after doing the encryption here, this is the encrypted image that we are getting. After that, we created a histogram for this image as well. You can see the intensity, and then we have the count as well. So this is what we have gotten here, and you can see it's evenly distributed right here. Then we went to the decryption step and we implemented step 6 decryption. This is again specific to every image that we will be decrypting. Then we use the encrypted image that we had in here and tried to decrypt it. So this is the original image that we started up with, and this was expected. We needed the original image after decryption. So this is what we have in here. And this is the histogram. So this histogram is meant to be same as the first histogram that we got. So this is what we have right now. Then we moved ahead with RSA algorithm with the image 2. So I have implemented exactly the same thing for image 2, but only the images are changed. So then I created 2 more variables. Then here I'm doing the image processing work, and again if you see I converted it to a specific size, and then I created the histogram for this one as well. So it has pretty more colors compared to that one. So that's how it looks. Then we went to the encryption, and after encrypting, this is what the image looks like. And we created the histogram, so this is evenly distributed again. And then we went to the image decryption. Again we used the last image that we got, encrypted image, and we created the decrypted one. It is same as the first one, and this was expected. Then we created the histogram is again supposed to be the same as we got in the first one. Then we did the same thing with the image 3. So image 3 is a portrait image. Basically, again, I resized it to what I wanted. So this is the resized image. And I created the histogram. Then again, I did the encryption step. So this is what it looks like after encryption. And this is what the histogram looks like. Similarly, I did the decryption, and this is what I have after decryption. Now I'm doing the encryption and decryption analysis. So I created, first of all, I created 2 Excels that would be storing all the data so that it's not a mismatched form. And this is what I have. Like first the one Excel is having the data about encryption time. Second Excel is having the data about decryption time. So this is what we have. We can even see it here that decryption is taking longer compared to encryption. So let's see what do we have afterwards. So this is the whole set of graph for image 1, image 2, and image 3. So the blue ones are showing you the encryption, the orange ones are showing you the decryption, and this is the time taken in seconds. So encryption just took like round about the first image's encryption took like 3 seconds and something, and then again was a little bit upper than 3, and then third one was too much. So if we can do our analysis from here, we can see that decryption always is taking lesser time compared to encryption, and encryption for the last image is way too much compared to the other two, because it has more colors and it was more detailed. So that was one reason that it took more time. So this is what we have on the table for RSA algorithm. Afterwards, I implemented the same thing like with the same 3 images in AES. So this is my Google notebook for AES. Now AES is pretty much similar to RSA because this is doing the cryptography stuff, but the way that it performs is different than RSA. RSA is pretty straightforward if we see, but AES has some specific number of steps, and it follows the matrix method for doing the encryption and decryption. So that's what we have followed in here. So let's start again. I have initiated a connection to my Google Drive because this is a different notebook, and also I am importing all the libraries that I would need in here, and I would just move ahead with it. So after that, I've created some variables that I would need for storing the time and everything in here. Now doing the AES algorithm on image 1. So first we are doing the pre-processing. So if you see here, this is the image that we have, the initial image that we had, the colorful one. Then I converted it into a black and white image. So the reason for doing so is that AES algorithm doesn't really perform well whenever we are dealing with more colors. So AES algorithm is more like it cannot take a lot of colors inside it, and it works well with the monochrome color, or like not too much messy colors. So that's why I converted it into a black and white image, and because it works the best with black and white image. And again, I resized it because we have a specific thing to maintain for every image that we have. So this is how I converted it. And after converting it to this image, now we made the histogram out of it. So again, the histogram will show you the intensity count. So here we are having the intensity count. Now moving ahead to the encryption. So the encryption has 4 different steps in AES. The first one is substitute byte transformation. So here we will make up the whole matrix, and then we will define the colors for that. Okay, so here we have done the first step, and this is what our image looks like afterwards. And as the next step, we created the histogram in here. So if you can see, it's evenly distributed, but this is not the final step. This is not what we'll say, okay, the encryption is done. After that, we went to the second step, that is shift rows transformation. So when we went to the shift rows transformation, so shift rows transformation is basically the very next step that we do after we are done with the previous one. So this is what we have after doing the shift rows analysis, shift rows transformation. Then we created the histogram for that, and histogram again, it's pretty different than the first one, but yes, we can understand that this is again like a lot of points are covered. Then we moved ahead with the mixed columns transformation. Then when we did the mixed columns transformation, so afterwards we are having this image, and the histogram looks like this. Okay, and then to the very last step of doing the AES algorithm is add round key transformation. So after doing this, we are having this image at the end, and this is what the histogram looks like. So it just shows us, if you see here, the intensity and the count of intensity, it's like just 300. But if you would have seen before, the intensity count was more, it's like 1600, and it was the same with every previous image. But after doing the very last transformation, we got a specific thing that, okay, this is the time that this is the count that we have for the intensities. So we stored the total time that was done for encryption, so that we can do our analysis, and so that we'll be able to do our analysis at the end. And then we added the round key then we did the decryption. So for doing the decryption, again we have to follow the same way, but bottom to top, not top to bottom. So it's like we start from the very bottom and then we go to the top. Like it's basically the inverse of everything what we did for encryption. So we did the add key transformation. So we are back to the second step that we were while doing the encryption, like basically the fourth step that we got. So this is what we have in here, and this is the histogram that we got from it. After doing the histogram, we went to inverse mixed columns transformation. So basically we are just going up the ladder for doing the decryption. So this is what we have in here. So we decrypted it by using the inverse mixed columns, and this is what the image looks like right now. And then we created the histogram for it. This is what we have. Then we did the inverse shift rows transformation. After doing the inverse shift rows transformation, we got this image. So this image we got, and after that we made a histogram for this as well. So this is what the histogram looks like, and at the very end we did the inverse substitute byte transformation. So after doing the inverse substitute byte transformation, we just got the very first image from where we started from. This is our decrypted image, and it's the same as from where we started. And then the histogram we made, and histogram is again same to what we had. So that's how this all is done. So if you remember, when we did the encryption, the last thing that we were having was going till 200 to 300, and here it's 4000. So from where we started, we were having a lot of colors and all, but with time they were all settled down, and then we got our encrypted image. Then we calculated the total time for decryption, and we have stored it. Now moving on, so this is the graph that I made, like time taken is in seconds, then encrypted step performed. So this is basically how much time it took for doing the encryption. And overall, if you can see here, the mixed columns transformation has taken the most time of all the things that we were having in here, right? So then if we talk about the decryption as well, so we are getting the same thing, like the mixed columns transformation is taking the most time. So this is just for image 1, not for any other image. So from image 1 we can do the analysis that yes, mixed columns transformation is the only step that is taking the most time from all the other steps compared. And then we did the AES algorithm on image 2. Again, we are following the exact same procedure. We are doing the we are first converting the image to a black and white, because it works best when there are not so many different colors. So we made the histogram out of it. Then we are doing the encryption, and after doing the encryption, it's again the first step process. We did the first step, that is substitute byte transformation. So this is what we got from the substitute byte transformation. We made the histogram, and then we did the shift rows transformation. The same way we got one image, and then again we did the mixed columns transformation. After doing the mixed columns transformation, we moved on and we did the add round k transformation, and add round k transformation is pretty much our last step. So this is what we have on table right now, and this is our final step. Then we did the decryption, and we actually stored the value of decryption parameters as well. So this is here I'm just taking you to a shortcut because it's the same thing. So I did image encryption, then this is the total time taken for decryption, then I stored the data in Excel for analysis. Then we did the same thing in image 3. We did the processing. So this is the image 3 that we had in RSA as well. Then we encrypted it the same way, and we calculated the total time. Then we did the image decryption. We calculated the total time, and then we stored the data in Excel to do our analysis. Then moving ahead, I went to encryption decryption analysis. So for encryption decryption analysis, I again imported the parameters that I would need, and then moving on, I did. So this is what we have at the end here. We have the image 1, image 2, image 3, and this is the time taken. So here if we see the image 1, like encryption time is pretty much the same, and even the decryption time is not changing a lot. It's pretty much the same, only for the first the decryption is the highest. So if we compare these two graphs, you can see the encryption is going even till 4, but here the encryption is just ending at 2. And for the decryption as well, it's ending at 2, so it's 2.5. The least is 2.5, so it's not like that much a good thing. So we can say that AES is performing far better compared to RSA, even though RSA was a straightforward approach. And afterwards, I have pasted, I have put all these images in my report as well, all the analysis that I got, and also I have uploaded these files on GitHub, so you'll be able to see them in here. And I have given the link in my report. Then that's how you should run it. You should be creating a folder in your drive and then uploading the images. So my images are also in the GitHub. So if you go to the GitHub, you will be able to see the images that I have. So this is the images that I have used. So if you pick them up and you put the program in the same folder and everything, you should be able to run it. And so yeah, that's how I made my project, and that's how you should be able to run it. So I guess that should be it for me. Rest of the things are mentioned in the report. as well. Thank you so much for listening. Thank you for your time. Have a good day.